Alright, 8th graders, it's Mr. KB back with another introductory lesson, or sort of walkthrough, another lesson or activity in MathLinks. So today we are looking at 8.2, and the learning target we're dealing with is this. I can convert, express, and describe connections between percents, fractions, and decimals. So this is kind of going to be the outline of our lesson. I'm hoping to do a little bit of mental math before we get started, a little bit of times table work just to make sure that we are keeping sharp. And then we will briefly review what we learned last in the last MathLinks lesson about 100 grids. And then we're going to jump right into the textbook. So I may not spend a ton of time on this, but basically we're going to be looking at, as a class, we'll be looking at the statistics that this goalie put forward. He stopped 9 of 10 shots. The second period saw 160% as many shots. So we'll talk about, if he saw 160% as many shots as in the first period, and he saw 10 shots in the first period, how many did he see in the second period? Yet an amazing 0.9375 save percentage performance held the Rockets in the game. Unfortunately, things took a turn for the worse in the third period. He allowed twice as many goals, despite facing only 1/4 of the shots as the second period, for a dismal 0.500 third period save percentage. So when you read the information that way, it's sort of confusing, but they've boiled it down into these statistics for us, facing only 1/4 of the shots. Yeah, so they've got all the statistics for us here in this table, and then we're going to brainstorm together how would we change or rewrite each phrase that contains a bold statistic so that it gives the same information but uses only percents, fractions, decimals. So we'll go back to these, and for example, this one, 9 of 10, we'll make that a percent. We'll make it a fraction. Well, I guess it's already in a fraction. And we'll make it a decimal. And then do the same for this, and so on. So what we're doing is we're just practicing using these different forms of expression in real-world problems. What I want to do next is go ahead and look at these different example problems and maybe work through them a little bit. So in example 1, we're converting percents to decimals and fractions. Express 160%, 0.45%, and 12.6% as a decimal and a fraction. One thing I would say as a warning, where is my marker? Why does it disappear like that? Stand by. Okay. I think when I zoom in, I have that problem with the marker disappearing. So I'll try not to zoom in anymore. Sorry about all the scanning. So this one right here is tricky because we always want to jump to say, oh, that's 45%. No, it's not. No, it's not. It's less than 1%. So it's, in my experience, that's the one that gives us the most problems. So we always have to keep in mind percent means out of 100. That's a helpful reminder. They talk about how to make 160% a decimal. Yeah, 1.60. I got a little confused here. Okay. 1.60 or 1.6. We don't really need that 0, right? 0.45%, we're just moving the decimal over twice to the left, essentially, to make it a decimal. In fact, that's what we're doing for all of these. They tell you to remove the percent sign and divide by 100, but really, I mean, what I recommend is, or something I guess to keep in mind is, every time you're dividing by 100, all you're doing is you're moving the decimal sign 2 places to the left. So in this case, 12.6% becomes 0.126. 0.45%, we move the decimal twice to the left. Add a 0 here and the decimal, and you've got 0.0045. Same thing with 160%. Move the decimal 2 places to the left. If there's no decimal, it's an invisible decimal right there, and that gives us 1.6. So we should have started with that hack right at the top. To write a percent as a fraction, write the percent as a fraction out of 100. So 160% becomes 160 over 100. 0.45% becomes 0. Oh, want to be tricky with this one. Want to be careful with this one because it is tricky. 0.45% equals 45 over 100 equals 45 hundredths. And then we're writing that as a... I'm not following their work very well here. This is where we want to end up. 45 over, I would go back here. We're basically writing this as a fraction over 10,000. Oh, I see what they're trying to do. They're trying to keep to this rule of a fraction out of 100. So you've got 0.45 over 100, which is the same as 45 over 10,000. Yeah, I mean, if it's me, I would just jump straight from here to, you know, basically to this. 45, excuse my messy writing here, over 10,000. So again, you just got to be careful of place value with this one. It is not the same as 45%. And then 12.6%, we've got 12.6 over 100. Yes, so I can see how they're processing this. You've got to get rid of the decimal. That's why they do this, and that's why they do this. And then you end up with 126 over 1,000 and or 63 over 500 to reduce that. All right, and then in number 2, we've got 3.26, 0.125, and 0.0032. Express these as a percent, a fraction, and not as a decimal. We're converting decimals to percents and fractions. All right, so as a percent, keep in mind that anything to the left of the whole is going to be a whole number. How can I say this correctly? Anything to the left of the decimal represents 100%, any numbers here. So for example, 3 equals 300%. And then everything in these two spots after the decimal represents over 100. So we've got 326%. You've got 12.5% based on these first two digits. That's 12.5%. And here we've got 2 zeros. That's why they're giving you that example. So that's actually not going to be a percent at all, or not a whole percent. It's going to be just 0.32%. So again, really simply, you're always looking at these first two place values as this is, you know, equals 100. And my circle disappeared, but oh, there we go. Now I'm going to have to undo. Yeah. Okay, and then going from decimals to fractions, yeah, you've got 326 over 100, 125 over 1,000, and 32 over 10,000. And then you just reduce those. Converting fractions to decimals and percents, that is maybe a little trickier. There's different ways to do this. I mean, with a calculator, yeah, you just divide the top by the bottom, 1 divided by 20, and that's going to give you I should just circle this part, 0.05 as a decimal equals 5%. Divide 71 by 200, that gives you, on your calculator, 0.355, which is the same as 35.5%. And divide 4 by 3 on your calculator, you'll get 1.3 repeating, and that is the same as 133%. So dividing by a decimal, that's going to be easier. Certainly with a calculator, it's definitely easy. Using an equivalent fraction out of 100. Let's look at the process there. So 1 over 20, basically, well, that's a bad circle. Basically, what this method involves is you're making an equivalent fraction. If you think back to our unit on proportions, I think that was our last unit, you're lining up two fractions. You're saying 120 equals what over 100, right? And so when you solve for x, then that gives you your value over 100, and then that gives you your percent and your decimal. Do the same thing here. 71 over 200 equals, obviously you're going to divide the 71 by 2, and you get 35.5. And we want decimals, yeah. So you've got 35.5. And then, 4 divided by 3, or 4 over 3, pardon me. This is the hardest one because 3 doesn't go into 100 evenly. So we've got to multiply by 33.3 repeating, and then that gives us 133.3 repeating. It's all this repeating. All right, example 4, converting percents with a fractional part. So 1.5%. I cannot overstate this. Be careful with the percents. Make sure you're thinking clearly about the place value. So 1.5%, we know that 1% equals 0.01. So 1.5% should equal the same as, another way to write this is 1.5%, or 0.015. All right, how can she, and the same thing with the 1 3/4%, how can she convert these values to use them on her calculator? So it is easier to enter decimals than fractions, yes. First, write the values as percents with decimal parts instead of fractional parts. So this is sort of what I just walked you through. You end up with 0.15, right, as 1.5%. And then the same thing down here. 1.75% is the same as 0.0175. And here they give you sort of a map if you get a little bit lost. How do you convert back and forth? I'm not going to read all of these arrows, but it might be handy. Might be handy. Then we get into the problems. So, how should I approach this? Let's just do 1 or 2 for each of these. So as a decimal, this is going to be 2.48. As a fraction, this is going to be 2, well, in terms of simplifying, that adds another layer. So let's walk this through. 248 over 100 equals, and we know for sure we can divide each of those by 4. So let's say this is, well, 25 as a denominator. And then this is going to be 62, I believe. 62 over 25. Is that math right? 60 times 4 is 240, yeah. Okay, converting each decimal to a percent and a fraction. Good, so we've got a tough one here. So, did I read that right? Each decimal to a percent and fraction. So, if I look at these first two place values, there's no whole number percent here. So, it's going to be, as a percent, it's going to be 0.72%. Not to be confused with 72%. I'll keep saying it so many times. As a fraction, so I just want to remind you what they recommended when you're converting one of these numbers to a fraction. They suggested, you go from, where's the original number? 0.45% to 45 over 0.45 over 100 times 100 to get rid of the decimal. I'm just going to go straight there, sort of skipping a step. So I don't like how long my percent stem is. 0.72%. Okay. And then as a fraction, so this will not be 72 over 100. This will be, oh, yeah, no. This will be 72 over 10,000. Sounds ridiculous, but basically what you're doing is you're saying I'm going to move the decimal over 2 places. So think of, I'll always go back to, 45 over 100. This by itself would be 45%, right? This is my arrow. Okay. This by itself, 45 over 100 would be 45%. But we're dealing with, in this case, 0.45%, which has to be, we have to move the decimal over 2 more places, or that's what they're doing by multiplying by 100. They're getting the decimal out of there to give 45 over 10,000. I find comparison is really helpful, right? 45% is 45 over 100. 0.45% is 45 over 10,000. Same idea here. Oh well. I want to get rid of that extra line, but yeah, 72% would be 72 over 100. 0.0072 or 0.72% would be 72 over 10,000. Okay, I probably talked too long on that one. A on this one. Okay, again, as a decimal, 1 over 250. So we can, this should be 0.004, but I'll show you the work on what this looks like on my calculator. So you can just type in 1 divided by 250. There's the bell. And then that gives you, why did you go away? 0.004. So that's the easy calculator method. Or if you don't have a calculator, you can always do that long multiplication. What about as a, so we did as a decimal and as a percent? Well, actually, once we have the decimal, the percent is fairly straightforward because, again, you look at these first 2 digits, there are no whole percents involved here. So all you need to do from here is say this is going to be 0.4%, right? Number 4, express each percent as a decimal, then write it as a fraction in lowest terms. Okay, so again, this is not to be confused with 503/4%. It is 503/4%. So as a decimal, it's going to be 0.0, and then remember these first two place values are mean over 100 or hundredths place. So there will be a 5 here. But then what about the 3/4? Well, they're being nice to us. 3/4 converts fairly neatly into a decimal, and we know this one, 7/5, right? So another way of thinking of this is, can I write over here? Yeah, can. Sweet. If we took 3/4% by itself, we would say, less than 1%. Come on, catch up to me here.
Morning, Tim.
Good morning.
Such a sunny day.
Is it?
I love it. Yeah.
All right, so 3/4% equals 0.0. So I remember it's less than 1. So converting as a decimal, it's going to be 0.075. And my ink is sort of disappearing here, but this right here is what I added to this. Just this 75 over 10,000. So I'll leave that there as an example. And then we're doing more of this converting here, moving from a percent to a fraction. Would be 2 and 30 hundredths, or to reduce, we would say 2 and 3/10. That's not a 10. And as a decimal, 2.3. Okay, my video is crossing the 20-minute mark, so maybe, we've got some more grids here. I don't think that stretches your skills beyond what we've already covered. So I am going to leave my video there. I really look forward to, I think these questions are really cool, where you have to sort of rank and compare. That's actually really helpful to build your understanding. So I look forward to getting into those questions with you, but I will leave my video here for now. Best of luck as you continue your learning with percent.